Nice. Hi, I am Osama Almurshed. I'm a PhD student at Cardiff University. Today, I would like to talk about one of the projects that we are developing now using Parcel and TensorFlow Lite to deploy distributed neural network using Raspberry Pis. As we all know, a lot of AI applications need some server to deploy the model to perform inference. It can be speech recognition or maybe image classification. Usually users will use cloud virtual machines, which can have some data privacy issues. And sometimes if they have a bad connection, they sometimes will run with will have a bad response time, which can ruin the user experience. Edge computing or fog computing can solve this issue, where you can deploy your own deep neural network in a cluster of single port computers or Raspberry Pis or even your PC. And we developed these tools that will take any TensorFlow model. Actually, the tools is under development now, but it will take any TensorFlow model and we try to divide it and run it over a given infrastructure. This is a simple example of, this is a simplified neural network. Usually neural network have a DAG. For example, this is a layer. The output of this layer will be the input for the next layer, layer 2, where layer 2 will produce output that will be fed directly to layer 3 here, and so on. The tools that we have developed will try to extract this DAG like this. Then it will try to deploy redundancy or replication for each layer in the Raspberry Pis to ensure reliability, and you notice also it can increase the speed of the inference. The tools will have two phases. The first one is splitting DNN, and the next one is layer placement. The first phase will take any pre-trained model. Currently, we only use TensorFlow because we will compress it, or the tools will compress it with TensorFlow Lite. Then it will divide each layer here and back them into Python functions. Then it's going to be sent to the computational resources. During this stage, usually the system will save the DAG to ensure during the deployment stage the dependency have to be met, and to ensure that by the end of the workflow, you will have the correct result. The second phase is layers placement. We used dynamic programming to go through the DAG. Also, we have a greedy denominator heuristic, which is also a heuristic algorithm that we have developed, which relies on Parcel to speed up the deployment, the decision-making process. Then it will pass the decision, the map decision, which location and the number of replication, and gonna pass it to Parcel to do the actual deployment. And all the machines will have TensorFlow Lite interpreter to perform the inference, where each function will represent a single layer of the neural network. We run a simple experiment with only Raspberry Pis without the cloud. Now it is Raspberry 4, and we tested it with 16 deep neural network, well-known models, such as MobileNet, ResNet, version 1 and version 2 also. As you can see here in blue, is the deployment, the distributed deployment or the distributed execution of each models, but without the greedy eliminator heuristic, the algorithm that we have developed that this tools relies on. And with the greedy eliminator heuristic, usually it can speed up the inference, AI inference over edge infrastructure by up to 20%. Yeah, we test this in Raspberry Pi 4, and in the future we are planning to do the same thing, but with a mixture between, let's say, Raspberry Pi PCs that runs on the edge and some virtual machines on the cloud, and we're gonna test them with the different internet connection, let's say 5G network and maybe fiber or 4G, to see how the heuristic algorithm will react with or will respond with give a different solution. And yeah, thank you for listening and give me the chance to present this project or this tools, and it's still in the, under development. If you have any question, please let me know, or maybe send me an email. I will be happy to to reply to it. Thanks.
Okay, and there's a question in chat from Matthew, if you want to ask that.
Yeah, when you put the neural network layers on different processors that are distributed, do you see any fall off in the efficiency of those processors as the back propagation and forward computations get distributed over the network you displayed?
No, actually, we didn't do any training. It's only inference, which is, I believe it's forward. There is no back propagation.
Okay.
But even though, to be honest, with the Raspberry Pi, it's a little bit slow comparing to a PC. I think also data management, and where, because what we did is that the output will be saved in a shared file, and the next function will take it to avoid like creating, because the tools will create a replication or replicas, where each replica, the data size will grow. And in this case, usually, I believe Parcel will serialize the data. And if we say you have 5 copies of the data, you will do the serialization 5 times, which will slow the performance. But with the solution that we have, which is saving the data on the file in a file, and the next function will pick up the.
Is Parcel managing and deploying the execution between those layers with those files, or is it TensorFlow multiprocessing?
Parcel.
It is so Parcel is actually transmitting the files of the tensors between individual convolutional layers. That's really cool.
Yeah, it's like managing the workflow, more like, because the data will be saved on a shared folder over the network. Yeah, as I said, to avoid replicating the data, because it will give more job for Parcel to do.
Yeah, but it's like a multi-package DAG, because TensorFlow and PyTorch are mostly about establishing data flow DAGs that run the tensors through the models, but then Parcel accepts it, which is also a data flow library. So it's like you're maintaining that connection through multiple different libraries that manage data flow DAGs.
Yeah. And to be honest, I think the way that we developed the function that manage everything, or the application, We have only TensorFlow interpreter that will take the name of the layer and the location of the data that's been processed by the previous layer. And after that, that function will be deployed in a specific location, and it will download the file if it's not locally cached in the Raspberry Pi. Yeah. But as you have mentioned, also I think TensorFlow have also distributed version where you can do everything I have mentioned now with only TensorFlow. Yeah, I believe that, but I haven't tried it.
I think it would be easier with Parcel the way you're doing it. But I've thought about trying something like this before, and so I'd like to read more about how you're doing it.